The problem is this isn't the nicest thing to work with, because this guy lives in a finite field, and then this guy lives in omega, this guy lives in characteristic 0. So the ideal situation, the situation we're going to get to, is we would like to replace this thing with something that takes the type Mueller lifts of the elements of the finite field as its argument, and is some kind of power series so we can go crazy with p-adic analysis on this and get our result. So this is number 2, this is lifting characters. Does anybody have a question at this point? Are you with me, more or less? Okay.
Yeah.
Okay, lifting characters. All right, I'm going to just define lambda is going to be epsilon minus 1, which I'm just going to do that for convenience of not having to write down epsilon minus 1. We want something that looks like epsilon trace of A is equal to 1 plus lambda t plus t to the p plus da 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 t to the p to the ps minus 1, where t is my Tm lift of A. Okay. So what's like the most naive thing we could do here?
Something get used.
So the most naive thing we could do is we could just take 1 plus lambda to the t, and we could take powers of it and we can multiply them together. And that would give us what we wanted sort of narrowly, but this would have convergence problems. So we're going to have to do something more clever than that to get something that converges and really gives us something that's analytic in omega. So that's what we're going to do.
Oh, thank God. I don't want to.
Sorry, Alex, why do you want this equality to hold?
Because this is living totally, I would like some kind of like power series thing that's using the type Mueller lifts, that's sort of totally living in characteristic 0 so I can do analysis on it. Whereas this thing is like, this is part of it's living in characteristic P and part of it's living in characteristic 0.
I guess what I don't understand is why you've expanded, like this thing on the right-hand side, the sum in T, what's it coming from?
This sum in T, this is the trace.
Oh, okay.
This is, I'm sorry, yeah.
Trace.
Wait, so this is just an equality, right? I mean, this is just true. The thing you've written.
Yeah, so I want the thing on the right to actually be some kind of like nice convergent power series, and not just this equation. Okay. So I'm going to write something down, and I want you guys to consider it as a series in X. So I'm going to write down f of x, y is going to be equal to 1 plus y to the x times 1 plus y to the x to the p minus x over p. I wish I had more space. So times that. 1 plus, I'm sorry, there's a p in here. Y to the p, 1 plus y to the p squared, x to the p squared minus x to the p over p squared, and I just want this to keep going on and on forever. So everybody have a handle on what this is? Let me say, what does this 1 plus y to the x mean? 1 plus y to the x, this is this Bernoulli type guy, so this is defined as being the sum I equals 0 to infinity x times x minus 1 times dot 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 x minus I plus 1 over I factorial y to the I.
So you're using the product of all these?
Yeah, the product.
What are you taking? What are like the coefficients?
What do you mean what are the coefficients?
Like, because if this is mod p, then...
No, this isn't characteristic 0, I'm sorry.
Okay.
So this is...
Oh, okay.
Yeah. So the idea is we want to totally export this problem into omega and leave characteristic p behind. Okay, so if I'm thinking of this thing as a series in X, I I can rewrite it in the following way. So this is going to be n equals 0 to infinity x to the n, sum m equals n to infinity a m n y to the m. Okay, so it comes from the properties of this funny binomial series that we don't have any m for anything smaller than n. And what we want to work with is we want to work with theta of t is equal to f t lambda. So I want to show you guys that if I put lambda in my second component, I'm going to get something reasonably nice. So here goes. So we're going to see that note. Oh, I'm sorry, and then for convenience, I'm going to write this thing like n equals 0 to infinity a n t n. Okay, so what kind of properties is this thing? A n is going to be equal to the sum m equals n to infinity a m n lambda to the n. And so we're going to see the following things. The order in P of an is going to be greater than or equal to n over p minus 1. So in particular, an is going to be in Q sub p, throw in this pth root of unity. And from this fact, we're going to get that this thing is actually in QP adjoin epsilon power series in T, and it's going to converge on this disk. Okay, so I feel like I've been throwing a bunch of formulas at everybody. What do we need to take away from this? So we wanted some kind of analytic thing, p-adic analytic thing that would have a property like this. Sort of the naive thing, you can take my word for it, it's not going to have good convergent properties, but we can use this series, we plug in lambda, and we get something that does have good convergence properties on this disk. When we want to do analysis on this thing to get our result. I'll pause a second. Any questions?
Can I go back here? I'm sorry, I got a little bit mixed up on this with the technical of A. So this thing in the exponent, the t plus t to the p.
Yeah.
So like this is an element of QP, right? Or maybe
t plus t
omega.
to the t. Yeah.
So I guess.
So this isn't something that's true. This is something that we want. I mean, it is true, but we're sort of.
Is it? Wait. Wait. So it is. This is a true statement.
Well, so we're trying to get something that's like a function we can extend to this disk that locally looks like this, that looks like this on the type ellipse.
So as t varies somewhat is what you're saying.
Yeah.
You want this to be true for all.
So yeah, we want something. We want some kind of function on omega that converges on a disk that on the type ellipse looks like this.
Looks like this thing on the right hand side.
Yeah.
Okay. But I mean, so I guess what I'm going like the right hand side being equal to the left hand side.
Yeah.
Is this?
This
Why?
is. So don't think about this equation too much.
Oh, okay.
Is we want something like upstairs that has this behavior. Does that make sense?
Okay. Yeah.
Yeah. Other questions? Okay, so